Hey everyone, welcome to a new video of Learn with Adeesha. I'm gonna be with you today. I'm Adeesha, in case you don't know me, and welcome to the channel if this is your first time here. Today, I'm gonna be chatting with you about a mathematics topic that has been learned for a long time and has been explored for quite a bit. You think you might know everything, you may not, but in case you don't, in case you do, I'm still here to help you revise for your IGs. So we're going to be covering the first section of the number toolkit, which is types of numbers. The first thing you need to know is that this is actually a very easy topic. There is not much to cover here, so yeah, just listen in and yeah, that's it. You don't need to do much else. So, we'll start out with integers, which are the simplest maths concept to even grasp. They're just whole numbers. They can be either positive or negative. It doesn't matter. All of them are integers. Whether it be -3 or +5 or negative 1 quadrillion or something, all of them are integers. So long as they are not decimals or irrational numbers or imaginary numbers or anything like that. But I don't think we're going to get into the realm of imaginary numbers. That's best covered in college. So the next thing is natural numbers, which are just a special subgroup of integers. They're positive integers. Since you already know what integers are, I don't have to do any more explaining for this topic. Now we move on to a bit more advanced things, but these are still easy. I don't doubt you. These are multiples, which are numbers that can be divided by the given number without leaving a remainder. So they are perfect dividers. Now, a common multiple is just a multiple shared by many numbers. It's more than one. It's not just one number that has this. It's not just one number that has this multiple. It can be 2 or 3 or 5 or I don't know how many. It just has to be more than one. Now, a factor is just an opposite of a multiple. It's just the perfect divider of a given number. For example, 3 is a factor of 18. Is 18 divided by 3 is exactly 6. But 18 divided by 5 is not. So 5 is not a factor of 18. Now something really important to know, or note in this case, is that factors always come in pairs. So there's never one factor just left alone unless it's a square number, in which case that's a special case. Because in that case, there's just one factor that's left all alone at the center. So let's take another case. Let's take 4 as an example. Of course, we have the normal factor pair of 1 and 4. So 1 times 4 equals 4. 4 divided by 1 equals 4. Yeah. And then the other factor pair that's there, since 4 is a square number, is just one number. It's just the number 2. That's it. The number 2 is the next and only factor pair left. Why? Because 2 times 2 is 4, as you might have noticed. Or I think you might have noticed this a long time ago. This is very simple. Now, that's just how to find factors. Now, if you don't have a calculator, this might sound a bit hard, but I'll teach you something. Divisibility test. This will make your life so much easier, okay? Even for me, these have come in handy so many times. So I'll just share this knowledge to you and hopefully you can use it to your own advancement, okay? Now the divisibility test for 2 is pretty simple. It's just if the last digit of the number you're trying to find out with the divisibility test is having a factor of 2, if the number that you're trying to find out has the last digit that is even, then 2 is a factor of that number. To put it simply, for any number a, b, c, d, where a, b, c, and d represent different place values of that number, if d is divisible by 2, then the whole number a, b, c, d is divisible by 2. Therefore, also b, c, d and c, d are also divisible. That's pretty nice, is it? Now, 3 is also pretty simple. Check the digit sum, which is what happens if you add up all the digits. For example, for the number 1, 2, 3, 1 plus 2 plus 3 is the digit sum. 1 plus 2 plus 3 is of course the same as 1 times 2 times 3, which I don't need to mention, but that's pretty cool, which is just 6. Now, if the digit sum is divisible by 3, in that case the whole number is divisible by 3. It's pretty simple. So 123, its digit sum is 1, 2, its digits are 1, 2, and 3. Therefore, its digit sum must be 1 plus 2 plus 3, which is 6. Now, since 6 is divisible by 3, then 123 is also divisible by 3. Try it with any of the multiples of 3 that you know of. It will work. Now, 4 is a bit more difficult, but I'm sure you can get through it. If the last 2 digits of the number are divisible by 4, the whole number is divisible by 4. But for something even simpler, divide the number by 2 times, or just halve it 2 times. If it passes, and if it's an integer by the end of it, in that case it's divisible by 4. 5 is pretty simple. Just check if the last digit is either a 0 or a 5. Now 6 is also pretty easy. Check if the number is divisible by 2, then if it's divisible by 3. Or if it's divisible by 3 and it's divisible by 2 after that. In that case, the number you have is divisible by 6, and 6 is therefore a factor of that number. Now 7 is a bit more complicated. Now let's take a number a, b, c, d, where a, b, c, and d again represent different place values of a number. Got it? Good. Now, for a number to be divisible by 7, 2d minus abcd, as in 2 times the last digit, then that minus the whole number. If that is divisible by 7, the whole number is divisible by 7. But if the number is still too big, then just repeat the process until you get a multiple of 7 or not. Until you get something that you know or not is a multiple of 7 or not. Now 8 is only a factor if the last 3 digits are divisible by 8, or if the number can be halved 3 times or thrice. 9 is a factor if the number can be divided by 3 twice in a row. And 10 is a factor if the number's last digit is, you guessed it, 0. So that's all for the divisibility test. Now let's move on to some other things. For example, we'll be moving on to prime numbers now, which are numbers with exactly 2 distinct factors. 2, only 2. The first one, itself. The second one is just 1. Now, here's an interesting fact. 1 isn't considered a prime number since 1 has only 1 factor, not 2. And by the definition of a prime number, it has to have exactly 2 distinct factors. Not 1, not 3, just 2. That means since 1 has only 1 factor, in that case, 1 isn't a prime number. Oh yeah, and just in case you didn't know this, 0 is not an integer because it's not a whole number. In fact, it's just not a number. Okay, keep that in mind. It might come for your exams, it might not, but either way, this is just a pretty minuscule piece of info. Okay. So, after this, we'll be having a square. A square is just this rule, okay? It's a rule. For any number n, the nth square, or it's just the square in the position of n in a sequence, is just n times n, or n squared. You obviously know how algebra works, so I don't doubt that you can understand this. Anyhow, next up is a cube, which is just a square multiplied by the base number. So for a number n, the nth cube is n times n times n, or n cubed, or n to the power of 3. Now a square root is the opposite of a square. That's pretty simple. And a cube root is, you guessed it, the opposite of a cube. Shown by this. Now a square root sign is shown by the root sign, which should be somewhere up here. And a cube root is just shown by the root sign with a 3 on the top left. Now a square root can also be shown by the root sign with the 2 on its top left. Now, here's something really important. A reciprocal. A reciprocal is just the reverse of a number. Got it? Now, the reciprocal of n will be 1 over n. And the reciprocal of a divided by b is b divided by a. So the reciprocal of 2 is 1 over 2. And the reciprocal of 1 over 4 is 4 over 1, which, as everyone knows, is just 4 divided by 1, which is 4. Got it? Now, something important to know is that always, when trying to find out the reciprocal of a number, just reverse it. But also, when trying to find a certain reciprocal of a number that you don't know, but you're given this equation, n times something equals 1. When trying to find something like that, the number in the middle, the something, is just the reciprocal of n. What I mean to tell you, in case you couldn't understand all that gibberish, which even I couldn't understand, what I meant to say was that any number times its reciprocal will equal 1. Okay? Now, this is just a bit extra, but for this unit, you will have to know the first 15 squares and the first 5 cubes and the 10th cube. Just don't care about the 6th to 9th cubes, I guess. I don't know why, but you can go find that out by yourself. Now, the first 15 squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. That's the first 15 squares. Now keep in mind that all these squares, their square root is, well, the position of that square. For example, the square root of 5 is 25, and the square root of 25 is 5. Now you could hear in my sequenced representation 1, 4, 9, 16, 25. Count the number of numbers that just passed. 1 is the first number, 4 is the second, 9 is the third, 16 is the fourth, and 25 is the fifth. So keep in mind this pretty interesting thing. Now the first 5 cubes increase a lot faster than the squares, okay? And the 10th cube is just 10 times 10 times 10, which, as you might know, is just 1000. The first 5 cubes are in order, ascending order, of course. 1, 8, 27, 64, and 125. That should be it for this video. Go and search online for some practice papers, or just check out Papa Cambridge if you're looking for some good study materials. Yes, I know that website. It's really nice, okay? So go check it out, and I hope I'll see you in some other videos. Goodbye for now, And this is Learn with Adeesha, and I'm out. Bye bye.